So next one, here you can see input in the middle. It also comes from the AND gate, and you can see that A, it is not inverted, and not B, it's inverted. For this reason, we connect it here. Okay, and last, what we should do, we should give input to the last one, input of the OR gate, and here it also comes from the AND gate, and you can see that AND A is inverted. For this reason, here we will connect to the inverter, and it is connected, you can see here, and also B is not inverted. So actually, for this expression, here you can construct the circuit that will implement this function. I think it's not difficult, it's clear. Yes? Okay. So here's a little summary. Notice that we started at the output of logic circuit and work towards the input. So actually we started from the output. So on the output it's OR gate, 3 input OR gates, and each inputs is connected to the AND gate. And here you should consider, we need inverter or just directly connect to the input. Okay, so next one, forms of Boolean expressions. So actually we have two types of Boolean expressions. First one we call the sum of products form, or just SOP, sum of products. For example, here you can see not A and B, or A and not B, or not B and C results Y. So sum, I think it means this or products, it means this dot end function. So it's other example. So this example that we've just considered, it's other example also the SOP form, right? But we will not use this definition. We mostly call it the min-term form because it's the same. The sum of products form is called the min-term form. So we'll call this min-term. Okay, other types, it's the product of sums form. So here you can see the difference. So first we do OR, then we do AND. Other example. Sorry, here it is a typo. This should be dot, okay? This should be dot. It's a typo. And also we will not call this product of sums, we mostly will call it max term form. So you should know, for example, you will see some Boolean expression and you can you should able to define it is min-term form or max term form. So it depends what we will do first. For example, here you can see we will implement AND function separately and then OR function. Okay, so next one. So we need to draw circuit from a max term Boolean expression. So max term, you already see, max term is this one. Okay, so suppose you're given the max term Boolean expression. So here you can see first A or B or C, and not A or B not equals Y. So here also have two steps. So let's consider first step. So you can see that the output Y comes from the AND, and you can see we have only to the AND we give two input, right? So first input it would be A or B or C, and the second input it will be not A or not B. So it's our result. So next we need to go to the sorry guys, a little bit noisy, so give me some give me a few minutes. So I back, can you see my screen?
Yes.
Okay. So we considered, right? We considered how can I eliminate this one? Okay. So it is our first step. So towards the outputs, signals comes from the AND gate. But you see that next we need to construct the inputs of the AND gate, right? What's going on? Okay. So it's our first step. It's our full max Boolean expression. So let's begin to step 2. So in the step 2, so let's start from one of the, it doesn't matter. You can start from the this input or from the this input. So you can see that signal should go from the OR gate to input OR gate, but signal should be inverted. For these reasons, we here add inverters. Okay. So next, we need to consider second input of the OR gate. So here you can see it's different. Here we have 2 input OR gate. Here you can see it is a 3 input OR gate. So you can see that it is not inverted. For this reason, we just directly connect to the A, B, and C. So that's it. So this circuit, combinational circuit, we call it. It's Boolean expression. It is real circuit that you can construct, and it will do this function. Okay. So it's some little bit summary. So what you should know: work from right, okay, from the right to left, from output to input when converting a Boolean expression to a logic circuit. So first you need to understand what is. If it is min term in previous, yes, in this case you should start from the OR gate, but it is a max term. The max term you should start from the AND gate. Then you just need to fit the input of the AND gate. Okay, max term and min term Boolean expressions both can be converted to logic circuits. So we see how can we do it. Actually, we'll do it in LambWorks and also on test, on practice class. So last lecture we also considered truth tables, right? Because truth tables, Boolean expression, it's actually the same thing, but we represent some logic gates. We can represent in Boolean expression or by truth table, but meaning the same. We can see what kind of signal we will have on the output, 1 or 0. So Boolean expressions are a convenient method of describing how logic circuit operates, but the truth table is another precise method of describing how logic circuit works. So sometimes you will have not Boolean expression, sometimes you will have the truth table. For example, it is a truth table. So what do you think? What kind of functions describe this truth table? Can you figure out from this truth table what kind of function it describes?
XOR.
Yes, it's XOR function, right? It's XOR, right? Because you can see that XOR function only when the inputs, number of inputs add, it will give us 1. For example, this only 1, this also 1. For this reason, we have 1, 1. But here, number of inputs, even numbers. For this reason, 0. In the last one, you can see it's 3. 3 is the odd numbers. Okay, truth table to Boolean expressions. So here, truth table and Boolean expressions, and here we need to, for example, we have this kind of truth table, and you need to write down Boolean expression to this truth table. So how can we do it? So it's actually very easy. So you should look only for combination of variables that generate a logical 1 output in the truth table. So it is your truth table and combination of the variables. What is the combination of variables? It's just, for example, 0, 0, 0, 0, 0, 1, 0, 1, 0. So it's just combination 1, 2, 3. So here you can see actually we have 8 combination because it's 3 input. when we have 3 inputs, we can have only 8 combinations maximum. For example, if we have 2 inputs, we can have only 4 combinations. For example, if we have 4 inputs, how much combination can we have?
16.
16, yes, right. So here you need to look just on the output, not just outputs that generate 1. So you can see this and this generate output 1. So actually it is A, it is a B, but this C is 0. For this reason we say it not C. So here you can see. So not C because it's 0. B 1 and A 1 is equal 1. And next combination you can see it's C because it's 1, not B and not A. It's 1. So next we need to OR because either this one will give us 1, either this one. It is an OR function. So here Boolean expression for this truth table, it will be not C and B and A plus C and not plus OR C and not B and not A yields results Y. So I think it's also clear, it's not so difficult. So anyway, read in the chapter.
I have a question.
Yes. You can ask.
So, what should we do if we have a lot of ones?
We need to
We
OR,
just-
for example,
we need to just
good question. Yes. For example, if we have here, for example, here 1 in this case, it will be C and B and not A equals 1. It should here you should add OR, okay? So it will be not 2 OR, it will be 3 OR.
Because it means that we have one table on this table that have output all ones but 1 0. Then we will need to just product them, yes, just adding or not.
Yes, in this case you will write this kind of combination, then write down plus, but plus it means OR. So you need to OR all of the combination. If all of them will be 1, and this means you will have how much? 7 this kind of combination in 1.
But it's difficult to sum up everything, all of them. Do you have another way to represent a Boolean expression?
No. We have this. You have only this way, but next we will study how to simplify. So from the truth table, actually, you need to this. You can only do like this. So you need to write Boolean expression for every output. Then you need to OR it. Then there is techniques, and we will talk about it later. It's called Carnot techniques, and we can just simplify. Okay. So it's a very great question, but do not worry. You will not do. Actually, you do not need to convert some complicated truth table to the Boolean expression because you will use just software. You will use Multislim. Okay, so I just want to show you how actually it is performed. But computer can do it very fast and it can simplify. Actually, it is not unsimplified. Then you can simplify this expression. So do not worry about that. But it's a very nice question. Okay, so next, Boolean expression to truth table. Here we did truth table to Boolean expression. This we do vice versa, oppositely. So here you have some Boolean expression. So you need to come up with a truth table. So it's just the same procedure, but we do it backward, right? So two combination of inputs here, A, B, and C generate a logical 1. So this combination generate logical 1 is this and this combination. Other combination will give us 0. So next you just write inputs, outputs. So we have 3 inputs, A, B, and C. So output Y, I'm added comp, it means combination. So I look first combination, 0, 0, 0, 0. It means not S, not B, and not A. So You can see not A, not, so you can see that here in this Boolean expression, we don't have this kind of combination. It means this combination will be 0, okay? So next, let's consider input. Actually, you need to write 1, 0, 0 because A, it's not first, but usually we just can say that A it's first, B and second, and C it's third, but actually it doesn't matter. So you can see it will be combination, it will be not C, not B, and A. Do we have this kind of combination here, this Boolean expression?
No, actually.
So what will be output in this case?
It will be 0.
It will be 0, right? So next, let's consider combination. Inputs 1, 0, 1, 0. So you can see, do we have this combination?
We have 1.
Yes.
Yes, it give us 1. So next, combination A and not B and, oh sorry, it's
Will be
typo.
0.
This typo, this C, okay? This C, not A. It will be 0. Next combination, not C, B, A. Do we have this kind of?
No.
No, it will be 0.
No,
This one,
Have.
1.
yes, we have, it will be 1. So I think, so we have only 2 inputs that generates 1, other should be 0.
0.
So the Boolean expression, this one, and the constructor truth table both accurately describe the operation of the same logical circuits. So actually it's the same, this one and this one. But this is more clear for us, yes, because we can see and it's not so obvious, but it's just shortened version to represent this truth table. And actually we can do some calculation by this expression. With a table, you know, it's very difficult to do some calculations. Okay, Boolean expression to truth table. Let's continue. Let's consider this kind of examples. So here, it's a min term or a max term. What kind of this one?
Min term.
Min term, because it's OR here, right? Okay, so let's consider inputs and outputs. So inputs CBA combinations, so 0, 0, 0, combination CBA. So what will be?
Will
What
be
is-
0.
Are you
1.
sure? Guys,
No. It will be 1.
it will be 1 because here it don't
We
actually
don't have
doesn't
B.
care. Yes, it may be B may be 1 or 0. So for the system it will be 1. So next one. What do you think?
No, we don't have
Yes, it will be 0. Here.
0.
Are you sure? Because we have CA and A.
Okay,
It doesn't
1,
matter
1.
what will be B. It doesn't matter. It will be 1. Okay. So this one is 0. This one is also 0. This one also 0. And last one. It's not last one.
So
This
teacher,
one.
we should consider 2 cases, yes? One
Yes.
is 0 and this one.
We have only 2 outputs will generate because we have here 1 plus. If we will have its min term, so maybe this combination, but yet actually here is 3 inputs generate 1, not 2, because it doesn't matter what will be B here in the first term. Okay. So actually you can here add, guys, you can here add just C and B or B not, so it doesn't matter. Three logical inputs. Okay, so I think it's clear. Circuit simulation conversation. So actually here I will show how can you do it by the Multislim software. So circuit simulation software running on modern computers can accurately convert Boolean expressions to truth tables or truth tables to Boolean expressions. So we will, of course, but it's not, you know, You can use other kind of simulator, but in our case, we're doing on the multisim. So I will show you how can you do it multisim. So on the multisim, this special function, we call it instrument logic converter. So how can you find it? So let me open multisim. Do you still see my, can you see multisim now?
Yes.
Yes.
Okay, so here on the multisim, just go to simulate, instruments, and here you can find logic converter. Okay, so you place it, and actually you will do it on the lab work. You can connect here some circuit and it will generate its truth table logic function, but you need to double click, and here you can type Boolean expression. So now let's consider some real examples. Here in the, let me continue. So this one, to convert a Boolean expression to truth table. Okay, we need to do it by the multislim. So, but guys, you need to understand, we need to rewrite because from the keyboard, you could not type this over bar. Instead of over bar, you just use this apostrophe, okay? And also you don't have this dot. For this reason, I just forget to reduce it. You will just, write C, B with apostrophe without this dot. Okay, let me show you on the multislim. Okay, let me actually copy this one and place here. So, so first C, right? B. So can you see there is no any dot? So computer, this software will understand that it means and, C and B. But here I need to add apostrophes and A also with apostrophe, right? Then plus, it means or, C with apostrophe, B with apostrophe, without, just B and A, right? Is it correct? Seems right. Okay, then here you need to choose, guys. What do we need actually? I don't know, resolution is enough, but here you can have, it is AB, it means Boolean expression. We need to convert from the Boolean expression, it is this button, to the truth table. I'm just click it, and here you can see truth table for this Boolean expression. So it's very easy. But actually I can, for example, press this button, and here it will generate actually circuit. So it will be circuit for this Boolean expression. Okay, so let's continue with our slides. Oh, it will generate this kind of okay. It is a truth table from this Boolean expression. Okay, I showed how can you do it by the multisim. So again, what is this truth table for? We already talked about. It is for truth table for sims for XOR. Yes. I don't know how can I don't know. Okay. So we need to write down. It is our truth table. We need to write down the Boolean expression for this. So you can see that 0, 0, 0. So we will not write down. 0, 0, 1. It means not A, not B, and C. So actually, it is the first one, right? So next one, not A, B, and not C. So or write down here. So it will be Boolean expression, but it's a little bit complicated. So actually, we can simplify this expression, but you can actually type this on the multisim, and it will generate this kind of truth table. So let's do it again. So I will just copy this one and file, new, simulate, instrument, and here you need to choose logic converter. Double click. Okay guys, so A with apostrophe, B with apostrophe, C plus A with apostrophe, B and C with apostrophe plus A, B with apostrophe, C with apostrophe, and last one, right? Plus A, B, C. So does it correct? Seems so. So next we need to choose this button and we'll generate a truth table. So we need to check it is really a truth table for XOR. It's 1, 1, right? 0, 0, yes. So it actually generates truth table for XOR. So it's easy. Let's try to generate so can you see it's complicated circuit, but actually we'll do it later. We can simplify. It's just XOR function, but here you can see actually it's create all of this separately. Okay. Let me do it again. Okay. So let's consider some sample problems. It's very interesting. For example, let's assume that we are designing a simple electric clock for fridge. For example, maybe you're living in dorm and your neighbor, eat your foods, and you decided to come up with some lock, electronic lock that will have some combination, and if you will actually type this combination, lock will be open. So, for example, this kind of electronic lock, so you want to design. So first we need to, for example, construct some truth table. Because the lock will be open only when certain switches are activated. So, for example, you want to have two kinds of combination. For example, one A0, B0, and C1. Output will be 1, and this lock will be open. Yes, and in second combination 1, 1, 1. So from this truth table, next you just convert it to the Boolean expression A, B, C, and A and B and C, or not A and not B and C yields Y. Okay. So notice that the two combination of input switches A, B, and C generate 1 at the output. So high output will open the lock. Okay, so next you need to make circuit. So actually you have two choices, guys. You can do it yourself. This one it's easy. It's understandable that you need to use OR gate. So because it's what kind of? It's min term or max term?
It's min-term.
It's min-term. For example, in this case, yes, right. Output will be connected to the OR gate. So it's OR gate. Then you can see that. But here we need 3 inputs AND gate, right? And A, B, C that connected directly to the first non-AND gate. And next input of the OR gate is connected also to the AND gate because it's. But here we need to use some inverter because A and B, both they are inverted, and C is connected directly. But let's try to type it on the multi-sim, this one. And see what multi-sim will new. Okay, so simulate instruments. What next? Logic converter. Yes, and we need to type A, B, C plus A apostrophe. Apostrophe means not inverted. B apostrophe and C. And next, let's check first of all truth table. You can see, and next circuit itself. Okay, let me remove this one. So here, this circuit that we generated from Boolean expression. Can you see the difference between this circuit and this circuit? What's the difference?
Difference of inputs of AND gates.
Yes, actually, multi-slim show us this both. Yes, this both. The OR actually it is two-input NAND gate and it's also two-input NAND gate, but they are combined such way that it generates us three-input NAND gates, right? This one, it's also it represents three-input NAND gates. That's it. So, but actually the same one. This one and this one, same one. So I will check to tomorrow's labs, but I think there is some circuit when I can actually. Then, guys, this one it goes to the some keyboards, right? These inputs. Of course, you need to connect some power, and this go to the. For example, it can go to some motors that will open or close the lock. So, but it is a heart. It will be heart of the electronic lock. This circuit. Because when we will, you know, actually, for example, you will press three buttons, 0, 0, 1. In this case, it will generate 1, and your lock will be open. Or you can use 1, 1, 1. And but actually, you can, you know, come up with other combination and add here. For example, here 1, and we'll have a lot of choice to open the lock. Okay, so it is actually what's the multi-slim generated, so it's the same with these ones. Okay, I think for now we can take some break and we'll continue. So, but I will just now I will open the access during this break. So please go on Moodle and record your attendance. Okay, guys, you can take a break.
Yeah.
Then we'll continue.
Okay.